Introducing DeFi language support for VS Code. My name is Eric Lau, and this is my project submission for HackMoney 2020. The problem that exists today is that IDEs provide generic support for programming languages and libraries. However, they don't provide any Ethereum domain-specific knowledge outside of Solidity. Developers typically need to use external tools to look up things such as Ethereum addresses, ENS names, token addresses, contract information, and so on. To solve this problem, I wrote a VS Code extension for DeFi support when writing NodeJS applications. This gives you live on-chain data, live market data, as well as programming model support for common Ethereum DeFi scenarios. Let's take a look. The extension is available on the VS Code Marketplace by searching for Ethereum DeFi. First, let's look at Ethereum addresses. Addresses, private keys, and ENS names are all detected in your source code. Above each address and private key are links that you can click on to bring you to the Etherscan page for mainnets and testnets. Private keys resolve to the public key so that you can verify that the address matches with what you're expecting. Diagnostic warnings are shown for checksums. An error is shown if an address fails checksum. Or if an address is not a checksum address, you can quick fix to convert it to a checksum address. You can hover over Ethereum addresses to see the live information for both the Ether balance as well as tokens. Also notice the live market data showing the price of the tokens as well as their total value. Next, let's look at ENS names. There's two-way resolution for ENS names, both from the address to the ENS name or from ENS name to the address. You can automatically convert from one to the other. Now let's look at some DeFi programming examples. Press Ctrl Space to do code completion, where you have options to insert various DeFi snippets or token addresses. A Uniswap trade is as simple as choosing the snippet, then doing code completion for the tokens that you want. Notice the live market data. Hover over a token address for its live data as well. Now let's see how this helps with using the pTokens SDK. Insert the snippet, paste the private key, then copy the public address shown. Now you can insert a snippet for generating a pBTC deposit address to tokenize Bitcoin on Ethereum, and paste the public address that you copied. Now let's move on to how this was made. This solution uses the language server protocol. This is the industry standard for providing language features in text editors and IDEs. The extension implements both a language server and a language client that communicates with each other through this protocol. This allows the solution to be easily extendable to any other IDE. For live on-chain data, this solution uses Infura as the Web3 provider, and Ember data for live market data for Ethereum addresses and tokens. The next steps for this project are to support local development blockchains such as Ganache, so that you can get live data for addresses on your local chain. Deeper programming model support such as contract interactions and other DeFi SDKs. And finally, to get this into the hands of developers to get feedback on it and to make it as useful as possible for writing Ethereum DeFi applications. Thank you for your time.